Hi everyone, it's Mr. H, and we're just picking up the video on properties of circles. The few properties that we should be aware of about circles include the following. Something is a line drawn between any 2 points on a circle. We call it a chord. So if I have a circle, and here's the middle of that circle, doesn't really matter here, but if I take one point, call that point A, and any other point, let's call this point over here B, or over here, anywhere, and we draw a line between those, that's called a chord. So really we could have an infinite number of chords on a circle, because we could have this chord right here, say let's call that from C to D. We could have a chord from here to here, call that E to F, go straight across like that. And so any straight line from one point on a circle to another is called a chord. Well, another property here that we should be aware of is that the right bisector of a chord passes through the center of the circle. The center of the circle. What does that mean? Well, let's actually draw this on this diagram and see how that works. The right bisector, well, here's the chord. And so if I bisect that, the right bisector cuts this chord in half at a 90-degree angle. It is always going to pass through the center of the circle. So if I take another chord here, call this CD, and I draw that chord, then that also is going to pass through the center of the circle, etc., etc., etc. And that's actually the next point. The right bisectors of 2 chords of a circle therefore intersect at the center of the circle. So there's those chords, there's the right bisector. Just to redraw what I just had, let's say that we've got another chord CD here. Those are going to bisect, or that's going to bisect this line. And then those 2 lines are going to intersect at the center of a circle. Really cool property of circles, and it also has to do with the property of triangles. Because if you think about it, if instead we were to draw a chord from A to D, and draw the right bisector through that, and we were to draw a chord from D to B, I didn't draw that great, but we were to draw the right bisector through that, what we'd find is we'd see this triangle ABD, that the right bisectors of all the sides intersect at the middle of that circle. And that actually, for those 3 vertices for a triangle, is known to be the circumcenter. The circumcenter of a triangle. Now, you're not going to need to calculate that right now. However, it is worth noting what the circumcenter is. The last property I want to talk about here is that there is only one circle, and I have a big blank because I'm going to say one unique circle, that passes through 3 given non-collinear points. Points not in a straight line. So, right, linear, straight line. So non-co means together, non-together in a straight line. So obviously if I have 3 points straight in a line, I can't draw a circle through those, right? You can maybe draw a circle through 2 of them, or through these 2 if it's a bigger circle, or through these 2, but you can't draw a circle through all 3. But as soon as you have 3 points that aren't in a line, there's only one unique circle that you can draw through those. There's my 3 points. I can't draw any other circle through all those points. I can't draw one that goes this way. That's not possible. It's going to miss one of those points. So there's only one unique circle. Likewise, if I have almost all 3 almost in a straight line, I'm going to be able to draw a unique circle through that as well. It's going to be a very large circle that I don't have the space to do, but you can see where that goes there on that page. And finally, just to finish this off, what do you do if it asks to find the equation for a line that passes through the origin and is perpendicular to a chord? Well, let's go back up here. What is that? Well, that is the equation, goes through the origin, perpendicular 90 degrees to this chord AB. That must be, just by looking at that, it's bisecting this side at 90 degrees. It is the perpendicular bisector, or the right bisector. And we did that earlier in our course. And you can go through the steps for how to draw a right bisector when solving that type of question. So there you go, circles. Really, really useful. Tons of applications in engineering and geometry and in many different things, architecture. Hope you find that fascinating, and as always, ask for help if you have any questions.